Hello and welcome to Ms. Ma's Advanced Functions class. This is 7.4, Trigonometric Identities. The first thing that we're going to do is define an identity. So an identity has an equal sign, but it's not an equation. An equation is only sometimes true, whereas an identity is always true. So if you think about something like x plus 1 is equal to 5, we know that this works sometimes, right? Example, if x is equal to 4, then 4 plus 1 is equal to 5, and it's true. But if x is equal to 2, then I know 2 plus 1 is not equal to 5. So it's only sometimes true, right? And usually we'd ask you to solve an equation, and then you'd find the x values for which it is true. An identity is always true. So it doesn't matter what value of x I put in, it should always work. So for example, 2x over 2 is equal to x. I know this is always true, it will always work. So that is why it is an identity. So the second thing that I want to talk about before we get started is to talk about when you're trying to prove something, how proving something that is true is actually more difficult than proving something is false. So for example, if I wanted to look at these 5 people right here and I said, all these people are wearing blue shirts. So all these peeps have blue shirts. Then I'd have to prove it in a certain way. If I said, okay, well, they're all wearing blue shirts because this guy right here, he's wearing a blue shirt. So if this guy's wearing a blue shirt, everyone must be wearing blue shirts, so it works. I know that that's not going to work out, actually, because it's not a true statement, so that is not going to work for us. So you do have to go through every single person and say, okay, no, this guy's not wearing a blue shirt, so that means that everyone is not wearing a blue shirt, so this is actually false. So we call this guy a counterexample because he's against the statement. He's proving that the statement is false, and you just need one counterexample to prove the whole thing false. To prove it's true, we'd actually have to prove true for every single case. And so it's difficult to prove something is true, right? So if we try this, the first example says prove that sine x plus sine 2x equals sine 3x is not an identity. So if it's not an identity, that means I just need a counterexample. And in the world of trig identities, it's easiest to use pi over 6, pi over 3, or pi over 4. Usually pi over 6 and pi over 3 are best. And that's because these are the special triangles, so we know the exact values for our trig ratios, and pi over 6 and pi over 3, if they don't work, then usually nothing works. Pi over 4, pi over 2, pi, those all have a tendency to work even if the identity is not really an identity, so you just have to be a little bit careful about that. Okay, so I'm going to use, let's say x is equal to pi over 6, just to make it easy. So in this case, the left side is equal to sine x plus sine 2x, and you should just write it out, the original. And so we're going to use x equals pi over 6, so sine pi over 6 plus sine pi over 3, because that's 2 times pi over 6. And I know sine pi over 6 is 1/2, and sine pi over 3 is root 3 over 2. For the right side, sine 3x is going to equal sine pi over 6 times 3, which is pi over 2. Pi over 2 is 1, so we can see 1/2 plus root 3 over 2 is not equal to 1, so the left side is not equal to the right side, and I have found a counterexample. To prove that something is true, I'm going to have to prove it true always. So what we could do is just take one side and manipulate it until we get to the other side. So I'm going to try that first. I'll write left side equals, so I'm choosing this left side just because it doesn't have, it has more stuff going on than in the right side. So you could write right side as well if you want. So pi over 2 plus x. And I know that this is an addition formula, so cos pi over 2 cos x minus sine pi over 2 sine x is equal to that. And again, I'm making sure to write the original question into it so that I get good form. Proving an identity is like writing a really good essay. You do need to have an intro, and then you have to have good content that isn't repetitive, and then get an answer. So make sure you have good form because you want to communicate to your audience. Okay, so cos pi over 2 is 0, and cos x is just cos x, minus sine pi over 2 is 1 times sine x, and so I get negative sine x, which is exactly what the right side is. You can see that's what the right side says. So the left side is equal to the right side. And you can just do a little slash here. Some people like to put a little square, or you'll write QED or something like that, just to show that you have actually finished your proof. Okay, so let's try this one. It says prove that cos x minus y over cos x plus y is equal to 1 plus tan x tan y over 1 minus tan x tan y. And so you could have used the one-sided version where you write left side or right side and then you manipulate it until you get to the next side. That's a little bit more elegant, but you can also use a chart for this. So if you find that both sides are a little bit complicated, you can write both in. So I'm going to write left side and right side and then see if I can manipulate both sides as I go. And don't forget that you need to write the original in to the question here. And the reason that I want to have a chart is actually because I don't want to move back and forth. So when you're proofing, you're not allowed to move things back and forth or to add to both sides or multiply to both sides. You have to just work with one side at a time. You can't do both sides at one time, like mess around with both of them. So I can't just add one and add one here. That's not going to work. It's not an equation, remember. It's an identity. So we're just going to manipulate this side first. So I'm going to go cos x cos y plus sine x sine y. I'm just expanding it out. And when you're doing an identity, you don't have to really have a good plan. You can just kind of go for it and see where it takes you. So just make an effort, and you know, that's okay. So here I'm not really sure what I want to do with that, so I'm going to move over to this side. So tan x is sine x over cos x, and the quotient identity is definitely one of the really most useful ones, over 1 minus sine x over cos x, sine y over cos y. So now I can see that, well, if I have a cos x cos y here, I'm going to put it over the same denominator, so cos x cos y plus sine x sine y, and you can see I'm starting to get what I have on the other side, cos x cos y over cos x cos y minus sine x sine y. And there is a temptation definitely to skip a few steps, and you should definitely resist the temptation, because you are again trying to make a well-communicated proof. So you want to make sure that people understand and are following along. So here I can see that I'm doing cos x cos y plus sine x sine y divided by cos x cos y over this thing, so I'm actually going to flip it over. And actually I would usually skip this step because it's a fairly simple algebraic step, but I have a sneaking suspicion that some people will have difficulty with it, so I'm just going to write it in. And that's what you should do if you think people would have difficulty with it. So because it's getting divided, I'm going to flip it over and make it a multiplication, because I can do that with fractions. So cos x cos y minus sine x sine y. And then I just cross out my cos x cos y. Remember, if you have a plus, you're not allowed to do that, or a minus, so watch out for that. And I'll get cos x cos y plus sine x sine y over cos x cos y minus sine x sine y, which is what I got on the other side. If you look at it, you can see it's right here. So it's exactly the same thing. So I'm done. So I'll write left side is equal to right side. Done. Alright. Next, and this is the last one, we're going to prove that tan 2x minus tan 2x sine squared x equals sine 2x. If you want to pause the video, you can do that right now and try to prove it on your own. So why don't you go ahead and pause. Okay, hello and welcome back, and you can see that I have solved it as well. So I just factored out the tan 2x and got 1 minus 2 sine squared x, which I know is cos 2x. I also know that tan 2x is sine 2x over cos 2x, so my cos 2x's cancel and I get sine 2x. You might have done this in a different way, and that is perfectly fine. Don't worry about it. You could have used the chart if you want. You can do a really you can expand this out and see if you get sine 2x, and that should work as well. But you can see that there are different ways to get it. So if you chose a different way and you still get the right answer, as long as you did all the steps correctly, that is perfectly fine and you would get full marks. But of course, in math, elegance is matters, so if you can find a nice, elegant, quick solution, that is definitely better for you. So if you have any questions, you can ask me in class. If you find any errors in my video, leave them in the comments below. And thanks for watching, and I will see you soon.